Every rocket does the same basic trick: throw mass out the back fast enough, and Newton's third law pushes you forward. But how they do that varies wildly. The simplest kind, a solid rocket, is basically a tube packed with rubbery propellant molded with a hollow core. Light it, and the whole exposed surface burns at once. Powerful, dead simple, and totally reliable. But once it's lit, there's no throttle and no off switch. It burns until it's empty. That's why solid boosters are used for raw shove at liftoff, not fine control. Liquid rockets trade simplicity for control. Fuel and oxidizer are stored separately as liquids, pumped into a combustion chamber by turbopumps spinning tens of thousands of times a minute, and mixed at the injector plate. Because you can adjust that flow, you can throttle the engine, shut it down, and in some cases restart it in flight. It's mechanically brutal to build, but it's what makes precision landings and orbital insertion possible. No single rocket carries enough fuel to reach orbit alone. Most of a rocket's mass is fuel and structure, not payload. So rocket stage, once a bottom section burns out, it's dropped entirely, engines and empty tanks and all. The rocket that's left is suddenly lighter, and the next stage's engines don't have to drag that dead weight any further. Fewer stages, less redundant structure, but nearly every orbital rocket still stages at least once. For decades, every stage was thrown away after one flight. Reusable rockets flip that. After separation, the booster flips around, reignites a subset of its engines to slow itself down, and uses grid fins to steer itself back to a landing pad or a drone ship at sea. It's the same liquid engine hardware as before, just asked to fire twice in two directions on one tank of leftover fuel. Solid, liquid, staged, reusable, different trade-offs between power, control, and cost, all built on the same simple idea: throw mass, go the other way.